Today we'll be learning about the concept of Newton rings. Okay. So for Newton rings, what is that we need to know? We should know about what is light and what are some of its properties, right? So what is light? We all know light is a form of energy. Then what is Newton rings got to do with light? Okay. So it is understood that light has two behaviors. One is called the wave behavior and the other one is called particle behavior. Wave behavior happens to explain few of the properties of light like reflection, refraction, interference and diffraction, etc. The particle behavior of explains reflection, refraction and phenomena like photoelectric effect. So both behaviors are encompassed with light. Now we'll be using the property called interference of light to explain the phenomena of Newton's rings. Now in order to know about Newton rings, we will brief out with what is interference. So what is interference? Interference is a property associated with wave nature of light. Right? Now in order to understand with what is interference, we need to define a principle called principle of superposition. Okay. So what is it? Principle of superposition. So the word itself is giving you a lot of meaning. Superpose means you are putting one over the other. What is that one that is being put over the other? Here you will be putting one light wave along with another light wave. One light wave along with another light wave, each produced by the same particle and having different displacements. And they have what is called different displacements. When these two light waves that are hit on the same particle but are producing two different displacements, when they mix together, you will get a resultant wave which can either have the displacement equal to sum of the individual waves or it is equal to difference of the individual waves when they move in opposite direction. If they move in same direction, the resultant is y1 plus y2. If they move in the opposite direction, the resultant would be y1 minus y2. This is called as the principle of superposition. So, to brief up, what is the statement for principle of superposition? The principle of superposition states that the resultant displacement of a particle of a medium that is acted upon by two or more waves simultaneously is equal to the displacement of the particle due to the individual waves in the absence of the other. Using the principle of superposition, we will try to explain the phenomena of interference. So what is interference? Interference is nothing but the explanation or use or application of principle of superposition. Then what is that you are trying to do in interference? In interference, I will take two light waves of different amplitudes and try to superimpose with each other. When I superimpose with each other, the resultant wave will have an amplitude distribution which is different from that of the incident light waves. This is possible because of the mixing or interference of the two waves. Thus, let us consider two light waves having say amplitudes A1 and A2. What is amplitude? Suppose if I have a light wave, this maximum displacement, I would call it as amplitude. I have another light wave. It is having a different displacement because the height of the peak is different. So this amplitude is E2. When these two light waves, they act simultaneously on an object, Then if you try to find out the resultant amplitude, then it will be a combination of A1 and A2, and it will have two possible cases. One is called constructive interference. The other one is called as destructive interference. So constructive and destructive. What is constructive interference? The resultant intensity which is coming from the superposition of these two waves with amplitudes A1 and A2 will be equal to the sum of these two intensities. That is called constructive, and if it is equal to the difference of these two intensities, it is called destructive. So there are only two cases possible, one being constructive, the other being destructive. Meaning you will have a very high peak or you will have almost a zero peak if the amplitudes are equal. Then A1 equal to A2, this becomes 2A and this will be 0, meaning this will give you a bright color and this will give you what is called as a dark color. Now, the important feature is that constructive and destructive interferences, they are not the types of interferences, but they are only the classifications which speaks about the resultant intensity pattern that you would get on the screen. Then what are the different types of interferences that we have? Let us try to find out what are they. Okay, how many types of interference we have? We have two types of interferences. Let us see about it. What is the first type of interference called? It is called division of wavefront. In which category we are doing this? These are the types of interference. This is called division of wavefront. Other type is division of amplitude, division of wavefront and division of amplitude. So what is division of wavefront and division of amplitude? Those two types we are going to see here. So in case of division of wavefront, the incident wave is divided into two parts. As the name suggests, wave is getting divided into two parts by methods like reflection, refraction, diffraction can be employed here. So I want to divide the wavefront from a single source. Why I use a single source? The interference has got some conditions like coherence, for which I need to use a same source. So I divide the source that is coming from, I divide the source into two or more parts and I will get what is called as different wavefronts, for which I am employing reflection, refraction and diffraction, for which I can use equipments like lenses, mirrors, etc. Okay, for which I can use equipments like lenses, mirrors, etc. What will they do? They will divide the incident wavefront into two parts and you will get two different waves which travel unequal distances in the given time interval, and they superimpose at a particular point, either giving a bright or a dark band on case of interference. Okay, so this principle is used in experiments like Friend's biprism. Of course, biprism is also one more instrument to get what you call different divided wavefronts, lens, mirror and biprism. Next one is called Lloyd's single mirror, etc. All these can be used what is called to get what is called as division of wavefront pattern. The other one is division of amplitude. The other one is division of amplitude. What is that we will do in case of division of amplitude? We would break the amplitude of incident beam by putting it on either by putting it on parallel surfaces so that reflection or refraction takes place at the edges and the amplitude of the wave is divided. Something like this. I have two surfaces. I'll incident a light here. some amount of light will get reflected and some would transmit to the next medium and which again hits here and which is again reflected and this will go in this direction and this will go in this direction. I will use some lens or some other kind of source so that both of these two things meet and I can get an image pattern here. This method of division of wavefront is used in experiments like Newton's rings, wedge method, Michelson interferometer, Fabry-Perot interferometer. So these are some of the experiments that employ the technique called division of wavefront. We'll stop here. We'll continue with the concept of Newton rings and the problems in tomorrow's class.